In daily cooking, we often use different tools like a blender and a stove, which take time and energy. But in other ways, we can use smart cooking to improve cooking efficiency, heat distribution, and food texture.
Before explaining how the system works, let's take a look at the main components of our smart cooking blender. These components work together to perform both blending and cooking functions. First, the measuring cup is made of BPA-free plastic. This material is lightweight, food-safe, and heat-resistant. Its function is to measure ingredients accurately before blending. The lid is made of polycarbonate plastic. It is durable and heat-resistant, helping to prevent spills during cooking. The mixing bowl is made of stainless steel. This material is corrosion resistant and conducts heat efficiently. Its function is to hold the ingredients while allowing effective heat transfer during cooking. The blades are made of hardened stainless steel. This material is strong and wear resistant, allowing the blades to cut, crush, and mix ingredients. Heating element is made of nichrome wire. Nichrome has high electrical resistance, which allow it to convert electrical energy into thermal energy for cooking. The motor contains copper windings and a steel core. Copper provides excellent electrical conductivity, while the steel core helps generate magnetic forces. The temperature sensor is made using a thermistor. Its function is to continuously monitor the temperature and ensure precise heating control. Finally, the outer body and control panel are made of ABS plastic.
Let's discuss about component of need. For question number 1, what physics-related need or concept are you addressing? This smart cooking item addressing the combination of mechanical motion and thermal energy. For question 2, which specific physics principles are involved? The specific physics principles involved are rotational mechanics and thermal physics. In rotational mechanics, concepts such as torque and angular velocity are important. For the torque, this concept describes how objects rotate. Torque is the force that causes rotational motion, and angular velocity shows that how the speed of rotation can be controlled. In thermal physics, concepts such as heat transfer, temperature control, and energy efficiency are involved. For heat transfer, it is required to distribute the thermal energy efficiently from the system to the material and ensuring that the temperature change occur properly within the substance. Second, the temperature control is important to maintain the desired thermal condition, preventing the overheating or underheating during a process. Third, energy efficiency is needed to ensure that energy is used effectively with minimal loss during the conversion of energy from form to another. What can we conclude that these physics principles form the foundation needed for the system to function effectively.
Component of need, question number 3. In what situation or real-life applications are these concepts important? The concept of rotational mechanics and thermal physics are important in daily food preparation. The smart cooking blender can be used to prepare soups, smoothies, sauces, and baby food. By combining blending and cooking functions in one appliance, it helps users save time and energy. These concepts also ensure even mixing and heating, which improves food quality. Therefore, the smart cooking blender is suitable for both household and commercial kitchen applications. Next, component of approach. Question number 1. How the system works based on rotational motion and thermal physics principles. I will explain how the smart cooking blender works based on rotational mechanics and thermal physics principles. First, the motor rotates the blades by generating torque. This allows the blades to blend, mix, and crush the ingredients efficiently. Second, the heating element cooks the food by converting electrical energy into thermal energy. This heat is used to increase the temperature of the ingredients during the cooking process. Next, heat transfer occurs through conduction. Heat moves from the heating element to the container and then directly to the food through contact. In addition, convection also takes place inside the blender. As the blades rotate, the food mixture circulates continuously, helping to distribute heat evenly throughout the container. Finally, blending and cooking occur simultaneously in a single system. This reduces preparation time, improves energy efficiency, and makes the cooking process more convenient for users.
In this blender system, several physics concepts are involved in its operation. First, torque. Torque is the turning force produced by the motor. When the motor generates torque, it causes the blender blade to rotate. The greater the torque, the easier it is for blade to cut and blend ingredients, especially harder foods. Second, angular velocity. Angular velocity refers to how fast the blender blade rotates. Different blade speed produce a different food texture. High angular velocity result in faster blending and finer texture, while lower angular velocity is suitable for coarser mixture. These concepts work together to ensure the blender operates efficiently and produce the desired blending result. Next, heat transfer play an important role in this system. There are two types of heat transfer, which is conduction and convection. What is conduction and convection? Conduction is when heat is transferred directly from the heated metal container to the food through direct contact. This process allows the food to absorb heat and cook efficiently. Convection is when the liquid or food mixture moves during blending. As the blade rotates, the heat liquid circulates throughout the container, distribute heat evenly and ensuring uniform cooking. Another important concept is temperature control. Temperature control maintains a specific cooking temperature throughout the process. This helps prevent overheating or undercooking and ensure consistent food quality and texture. By combining heat transfer and temperature control, the system can cook and blend ingredients efficiently while producing consistent results. This slide shows physical process, mechanism, and equation involved in the blender system. First, torque. Torque is the rotational force generated by the motor to spin the blade. The relationship is given by the equation T equal to I over alpha, where T is torque, I is the moment of inertia, and alpha is the angular acceleration. Higher torque allows the blender to rotate the blades more efficiently, especially when blending thick or hard ingredients. Second, angular velocity. Angular velocity describes how fast the blade to rotate, and it's calculated using omega equal to theta over t, where omega is angular velocity, theta is the angle rotate, and t is time. A higher angular velocity means faster blade rotation, resulting in quicker blending and smoother food texture. Finally, heat energy. Heat energy is involved when the blender heats food during operation. It is calculated using Q equal to mc delta T, where Q is heat energy, M is the mass of food, C is the specific heat capacity, and delta T is change in temperature. This equation shows the amount of energy required to increase the temperature of the food. Together, torque, angular velocity, and heat energy enable the blender to efficiently blend, process, and heat food to achieve the desired result.
For question number 4, what outcome or effect can be observed from the system? The first outcome is evenly cooked food. Heat transfer through conduction and convection spread heat uniformly. So, the food is cooked properly without any undercooked or overheated area. The net outcome is faster cooking time. Simultaneous heating and might sing increase the rate of heat transfer, allowing the food to cook more quickly. But if we stir the food while it cooks, it can make our meal ready in less time compared to the traditional method. Another outcome is improved energy efficiency. The system converts electrical energy into both heat and mechanical motion. At the same time, it reducing energy loss and making the process more efficient. Finally, the system reduces manual effort. Since both mixing and heating are automated, less human intervention is required during the cooking process.